Hi, it's Mr. Miller here, and since we're going to be gone today to literacy training, I'm going to make some videos of the review that you can watch, and hopefully this will help explain some stuff to you. Starting off, this is the first video with problem number 1 through 10. First thing here, it says, name 3 points that are collinear. Collinear means on the same line. All right, we actually have some choices in this problem because we have 2 lines here. We've got this line that goes down through the plane, and then we've got this other line that is on the plane. So as long as you name 3 points, it's on one line or the other, you're okay. So we actually have 2 answers here. We've got R, Q, and S, which are on line L. If you see these lowercase cursive letters like that L right there, that is the name of the line. That is not a point. You'll notice there's no dot associated with it. Now the other ones we have are T, Q, and N, which are on line M. Again, that's the name of the line right down there. You do not want to use point V. It's not on either line, and P here is not actually a point. If it had a little dot, it would be a point, but it doesn't. P is actually the name of the plane. This is plane P. So when you do this, as long as you pick 3 points that are on the line together, I mean, most of the time you could put your pencil down like this, and all the points should be underneath it if you're doing it right. So there you go. That's 3 points that are collinear. C. Draw and label a diagram for various things here. Okay, we'll start with A. Array with endpoint X and containing point Y. So it needs to start here at X. It goes forever in one direction. At some point, it contains point Y. That's what you need to see. B. A segment with endpoints A and B. There's A. And there's B. Last, a line containing points J and K. There's J and K. My line needs to go through them. Uh-oh, I kind of missed K there. There we go. And there's line JK. Of course, the test will be multiple choice, so you just have to pick out the right one. All right. Number 3, if AB is 17 and AC is 31, find the length of segment BC. This uses a thing we call the segment addition postulate. And when you look at something like this, in the middle there, we know that AB plus BC equals AC. And that basically what that's saying is this piece plus this piece should equal the whole thing. Oh, you know what? I'm going to move that over here. AB plus BC equals AC. Now I've got some of the values for it. It looks like AB is 17, so I can replace AB with 17. Up here it says AC is 31. That's the whole thing, and BC is what I'm missing. So 17 plus BC equals 31. That's a simple one-step problem there to solve. We're going to minus 17. Make sure you do it on both sides. That 17 cancels, and BC equals 14. All right. Find the distance between the points 2, 7, and negative 3, 4. Well, let's see. I'm kind of running myself out of room here. So I'm going to leave that stuff up there. And I'm going to do this one off in the margin so I can get back on track here. I've got 2, 7, negative 3, 4. And if I remember correctly, it wants the distance. Well, the distance formula looks like this. Square root of x2 minus x1 squared plus y, nope, not y squared. Hold on a moment. y2 minus y1 squared. Now, if you're getting skilled at this, you don't have to do this, but sometimes to keep it straight, I like to label these points up. I'll make this point 1 and this point 2. That makes this x1, y1, and this x2, y2. So now I can just plug the stuff in. It shouldn't be any big deal here. x2 is negative 3 minus 2 squared. y2 is 4 minus y1, which is 7 squared. And now I do a little trick because I know I have a habit of forgetting to square root at the end. I always like to write the square root down at the bottom so I remember to do it. And if I don't finish right there, at least it'll be there as a reminder saying, hey, why is this here? I need to remember to square root all that stuff. So let's look here. Negative 3 minus 2 is actually going to be negative 3 plus negative 2. And while I'm here, I'm going to change this to plus the negative. So negative 3 plus negative 2 is negative 5 squared plus 4 plus negative 7. Let's see, it's more negative than it's positive, so it's going to be negative 3 squared, and don't forget we're going to square root all that stuff. Now negative 5 squared, and you got to watch right here, this is a very common mistake. This is not negative 25. Negative 5 times negative 5 is positive 25. Negative 3 times negative 3 is positive 9. I'm going to square root all that. I'll go ahead and jump to my pre-written one here. That is square root of 34. I don't know what the multiple choice is going to look like, so you might have to approximate that with your calculator. It is approximately 5.83. Okay, if you need to look at that some more, pause it. Otherwise, it's going away. You can back the video up if you need to. All right. Number 5, find the midpoint of segments with endpoints negative 4, 5 and negative 8, 4. The midpoint is found like this. You average the x's and you average the y's, and that is your coordinates of your midpoint. So let's see, I'll label these up again just like before. I'm going to make this point 1 and this point 2. So that'll be x1 and y1, and that'll be x2 and y2. So now I just have to plug them in there and I'm ready to go. Negative 4 plus negative 8 over 2, and 5 plus 4 over 2. All right, negative 4 plus negative 8, that's negative 12. Negative 12 divided by 2 is negative 6. 5 plus 4 is 9 over 2. 9 halves. Now it's going to be multiple choice, so be prepared to see negative 6, 4 and 1 half, or negative 6, 4.5, all of which are equivalent to 9 halves. All right, number 6. Let's see what we got here. We got a diagram with angles PQR, RQS, and SQP around the outside. And it looks like we've got some algebraic expressions for the various ones here. It looks like an angle addition problem, kind of like the segment addition problem we had before. Let me rope off some area here. So for this one, I'm going to take this small angle right here, which is angle PQR. I'm going to add this little angle right here, which is angle RQS, and that equals the entire angle from here to here, which is angle SQP. Well, let's see. We have values for all of those. SQP is right there, so it's 71. PQR is right there. It's 15x minus 6. And RQS, you have to recognize that RQS or SQR is the same thing. So this could have been named RQS as well. So I can put that value right here, 3x plus 5. And this doesn't look too bad. Combine like terms and solve it. Let's see, 15x and 3x is 18x. Minus 6 and plus 5 is minus 1. So let's see, we'll solve this. Plus 1 plus 1. 18x equals 72. Divide by 18, divide by 18. And x is 72 divided 18, I believe, is 4. Now, whenever you do one of these, you always want to ask yourself, what did it ask me? Did it ask me to find x? Did it ask me to find a certain measurement or what? I always encourage everybody to go back and look and check the problem and say, what is it really asking me for? In this case, we found that x is 4, but it really wants SQR, which is 3x plus 5, and PQR, which is 15x minus 6. Well, we better put 4 back in there and see what those are. And while we're at it, let's check and make sure they add up to 71. Now, it's a pretty common trick on multiple choice tests. Don't be surprised if 4 is one of the answers. They'll try to get you to answer that without doing the rest of the problem. 3 times 4 plus 5. 12 plus 5, 17. That's this one right here, 17. 15 times 4 minus 6. 15 times 4 is 60. Minus 6 is 54. Do those two things add up to, what did it say, 71? Let's see, 54 plus 7 is 61, plus 10 is 71. All right, looks good, and I didn't stop too soon when x equals 4. Whoa, we got a lot of space for this one. Name this angle 3 different ways. Well, you can always name an angle based on its vertex as long as there's nothing else happening there. So we've got angle y. Now, when you've got multiple angles like this, then you can't use that one because I wouldn't know if you're talking about this one or this one. But when it's all by itself like that, angle y is a perfectly good name. Now, we can follow our other angle naming methods, which is any point on one ray, and then the vertex at any point on the other. So the y has to be in the middle. So we can go x, y, z, or we can go angle z, y, x. Either one, it doesn't matter. Now there's actually one other way to name these angles like this, and this one doesn't have it, but sometimes there's a number in here, like a little 3, then you can call that angle 3. But that doesn't apply in this case since we weren't offered that option. If angle R and angle S are complementary and angle S is 55, what is R? Okay, complementary. It looks like the question below is supplementary. So you got to remember what complementary means and what supplementary means. I always remember that complementary are the ones that add to 90. Supplementary is 180. 90 comes before 180. C comes before S in the alphabet. That's how I was taught to keep it straight back in the mid-80s, and it still seems to work okay. You need to get that committed to memory before the test so you don't mess it up. So let's see. If these two are complementary, then angle R plus angle S equals 90. Well, S is 55. That can go right here. Angle S, sorry. And angle R is unknown. R plus 55 equals 90. Subtract 55, subtract 55. This will cancel. Angle R equals 90 minus 55 is 35. All right, the next one we already discussed, supplementary. That means 180. So angle A plus angle B equals 102. Angle, not 102, pardon me. They're supplementary, thinking ahead. So they equal 180, that's better. A is 102 plus angle B equals 180. So minus 102, minus 102, and angle B equals 78. Okay, 2 more to go in this video. Classify the figure below based on the number of sides. Well, let's see. It's got 1, 2, 3, 4, 5 sides.